picking up where I left off earlier on. I had an inquiry recently from a young guy. He wanted me to design a pasteurizer, and it turns out he's a university guy, and I think he was hoping that I give him all these secret equations, but no one does that. So he asked me to design a pasteurizer system for him, for his project, to go into his project, obviously. And so I did that. I actually, basically, it was a hard cider pasteurizer. So you come in with that, I think it was 8 degrees C coming in. You go through a regenerator, pack of plates, which has, or there's different names for it, regenerator, interchange, intercooler, and so on, where you recover energy from the returning stream. So you come in at 8, and I think we came in at about 65 from there, which is a very, quite high overlap actually. And then you come out of there into a heater, and then the heater brings it up to 72. You come out that, so they're using hot water in the heater. I think it was 95 coming in. And then you go out of the pasteurizer into a long tube, which has a residence time. I think he wanted 28 seconds. It was a long residence time. So it was quite a long tube, big tube actually. But there are ways to change that and be a bit sharper about that tube. I've got ways to in fact get rid of the tube completely. And then you come back through to the regenerator, returning at supposedly 72, which of course you can't come back at 72 because you've lost a bit of heat along the way, unless you're a bit careful. So with that kind of thing, there's a few tricks to keep the heat there, in fact even partially heat it up on the way if you want to. And then you come back to the regenerator in at nominally 72, and then you pass it back out at about 15, I think it was 15.3 degrees C, against the incoming cold stream. And then you take the 15.3 and you drop it down using chilled water, in this case, used ethylene glycol mix, and brought it down to 8 degrees. Now, him asking me, well, can't you use cooling water? And I said, well, no, because when you've got plates, anything with water in it literally starts to get to the freezing point, and at about 4 or 5 degrees C you start to get ice crystals forming. It doesn't form exactly on 0. It's a gradual process. So you've got to prevent that. And knowing plant, if you ever made a plant and you've got maintenance, someone's going to forget and just pour water into the system at some point, and then you're going to end up with a problem. So I just gave it quite a fair margin. So it had a freezing point of about -10, I think, on that. And that was a really interesting design. But the biggest thing with the pasteurizer, all the plates have to be the same dimensions. And if I remember rightly, I think the cooler, the two of them, I think the regen and the heater were H, in other words, hard plates. Very good heat transfer, high pressure drop though. And I think the cooler was an L plate for that, which is a lower pressure drop, and that seemed to balance quite nicely. So with my software, it's quite nice. You can actually go in and actually set it all up and put in the streams, and then actually look at what comes out and then adjust it and optimize it. So I optimized the design. And then now the question is, what does he do with all these sheets? I give him all these data sheets. And then so I had to teach him a method where you go in reverse. I call it the reverse engineering method, but it's reverse engineering, but you're trying to understand whether it actually makes any sense. Okay, and so you reverse engineer back from that using standard equations, and you come up with parameters that make sense. So typically at universities they probably have to show some type of calculation. I think he was hoping that he would be able to show that he was a genius, but it's not like that because a lot of it's hidden. And so we can't give that all to you. But there are techniques, and then you can prove, okay, I did this, this, and this. And from those bases, I can get to an answer. Or you can work backwards. We call it basically reverse engineering sanity test to see if it makes sense. So this is something that he, I guess, would have put into his project. But this is the kind of thing that you can do with the software. So I'm actually busy doing an academic version where you can actually, the universities can learn how to design plate exchanges, because what's out there at the moment on the market for plate exchange, enormous prices. They won't even talk to you if you've got the wrong type of email address. If you've got a Gmail address, oh, you're not serious, give us a business one, Yeah, so what I've also done is the reason I've gone into a lot of the online work now is I actually got bad COVID, actually. I got bad COVID in March, roughly 2 years ago. And I was in a very high density situation, and and the people that were there were not really testing properly. And I ended up getting Delta, which really, it hurt me. We'd had a lot out here of COVID since the end of 2019. In various shapes and forms, but this really got to me in very high temperatures and so on, and I was in trouble for a while. And then I ended up getting long COVID. I managed to look after myself at here, because it's quite tough, getting medical treatment out here. And then I got long COVID, and I was paralyzed actually in my legs, and my arms were almost paralyzed for quite a long time. And I nearly died 3 times. So it's been quite an adventure. And as I've come out of that, my days of international travel, even though I'm mobile now and doing my thing, but I don't want to travel as much as I used to. So I'm basing it from home. And then I've taken on some work with people like groups like Fiverr, Upwork, and so on, where I've set up projects. And I've had people come and ask me along the way. And so I've set up projects to design plate units, or optimize your plate units, to design shell and tubes for you, to design extended fin units. And it's pretty cost effective. I don't charge too much for it actually, but it's fun work. So if you do have anything out there that you want to design, get hold of me. Go and look me up. You'll find me on Fiverr. You'll find me on Upwork. Some of the other forums I haven't been too impressed with, so I've kind of given up on some of them, to be totally honest with you. They're not that good. You get lots of scammers coming on. But I am a heat transfer expert. I mean, I've got a library here par excellence of stuff, and an online library as well. I've got a lot of information, so I do know what I'm doing. And when it comes to heat transfer, and even if you've got something that's a new process, I mean, for instance, a heat pump, I can put a heat pump in my hand, make it so small. It's no problem. I can do that. I've actually got the technology to do all of that. I've got a lot of technology. For instance, the pasteurizer. I've seen people do things with heat pumps. I can actually do it. They're trying to extract energy out of them everywhere, but you don't need to. I can actually make a system design a system that takes the energy from one part of the pasteurizer and gives it to the other, and with very little makeup required. So but you really have to know what you're doing, and you've got to design your circuits accordingly. So, in my hot water heat pumps, I've made water virtually boil, actually, and you can make it boil if you get the right refrigerants. So I've done all these kind of tricks. So exchanges are fun, and I certainly can help. Do know what I'm doing. And I've had some very big units. One of the energy recovery units I designed in my younger years was actually, well, there were a few, but one I remember, it was for a big crowd called Bison Board, and they were trying to recover, for instance, if they had waste steam, what do we do with this thing? Now, if the boilers, let's say they let go and they go through relief valves, it's just gone to atmosphere, and that's expensive, just wasting. So they wanted to recover it. So I designed this unit. And it actually was so good that it literally normally almost knocked out about 3 boilers when the one went going. But that kind of thing, and I've designed energy recovery systems for these kind of people. So I've done all kinds when it comes to heat transfer, and I enjoy a good challenge. Often with heat pumps, for instance, what compressor do you use? And you'll get some of these R134A compressors are very flimsy. So we actually go for a different compressor. And a compressor doesn't know what fluid's in there. There's no idea. So there's tricks on how to, and if you work with good refrigeration people, you can do a lot of tricks with all of these. People are using propanes and all kinds of things now. So that's me. Sorry if there's a bit of a step between this and the previous video, but my wife walked in. So I can help you with all kinds of designs, and I'd be quite happy to do that. I enjoy it. I'm set up here. I've got an office at home. I'm surrounded by computers actually, where I do a lot of simulation work. I do CFD work, analysis of certain things. But CFD as in sane CFD, not just CFD for pictures. It means nothing to them. Most kids today go and play with pictures and they don't understand really what's going on. There's a few problems when it comes to fluids. When we design with fluids, we have laminar flow. We always taught about that. We told, laminar flow, fine, low pressure drops, but very, very bad heat transfer. And then we've got an area there that say, don't go there, crocodiles. And then there's another area called the turbulent, fully turbulent. And so we generally design a fully turbulent. Why? We have better heat transfer, but we have high pressure drop. So my research has all been in the area where the crocodiles are, in between, the transition zone. And that's actually a wave zone. So what's actually happening effectively, you've got wave formation, the damping from the laminar zone. After that you go into a wavy type situation. And I've been studying that and writing academic papers on that. So part of what I do is being an engineer, but also being an academic, to try and go forward in some new ideas. So I did a lot of work on that, and I have over the years. So if you're looking for someone who knows what he's doing on heat transfer, please just look me up. You'll find me online. I've got my own website as well. These videos will probably end up on YouTube. And I'll have to clip the first one, I think, because my wife walked in. But they'll end up on YouTube, and then you can look at it and see who I am, and I can help you in what you're doing. I'd love to, because I've literally nearly 40 years in this business, and there's not much you can tell me about heat exchangers. There's lots of stories that people have, but heat exchangers are heat exchangers, and we can find ways to solve your problem. I've had some massive ones, actually, really massive ones that have come through as well. The shell and tubes, as I say, I use good software for that. I've used chem stations, what used to be AAA thing. I'm quite comfortable with that for shell and tube. There's a few issues also with shell and tube. People tend to use these single segmented baffles. There are others, but single segmented, and they get it wrong too. In fact, in terms of the pitch versus spacing, there's a few rules, and sometimes the flow is just really, really awful. And I mentioned earlier in the first part about modular exchangers, we use a spiral baffle there, which is very different, So you're spiraling the flow around and around. And so I've been developing also a high pressure version of those units. And I'd love to get some people to do some building for me, or to collaborate on these as products, because they're fantastic. And you can literally have a shelf full of parts and build something quite exotic. Some of these units can go up to 48 modules, 12 in parallel, 4 in series. It's very, very easy to update and modify them. You try and modify a single big shell and tube, it's impossible, because what happens is with a typical shell and tube, you're going to have to multi-pass on the tube side, and then you've got your shell side typically passing in one direction, but sometimes not, And then, of course, you end up with cross-flow correction factors over there are quite low if you're not careful. But when you use these modular designs, you've got a cross-flow correction factor of 1, typically, because we set it up in pure counterflow. And so we're much, much more efficient, and we can control things very carefully. We design the tube side, get that spot on, so that we don't end up eroding tubes, or we don't also drop out at too low a flow rate, fouling, and then you start to adjust the shell side until we get the heat transfer and the pressure drops that were acceptable, and then that becomes the unit. If it gets too long, we just wrap it around. We have a certain wraparound units. It's like a Meccano. That's fun. So anyway, this is just an introduction as to what RareTech does and who's behind RareTech. That's me, and my wife does the admin side of things for us over here. And we're based over here in Vientiane, Laos. That's where I've ended up, in this part of the world. But I do things online, and I can certainly help you. And I think I said earlier on in the first part of this, I've been through over 36 countries, so I've done my fair share of traveling on aeroplanes. At one stage it was 80% of the month. Anyway, but thank you so much for your time, and I'll put this up also on the RareTech site as well, and I'll put it up on YouTube as well. I'll have to clip the first one. But anyway, thank you very, very much for your time. I wish you well, and I'd like to see you along. Take care. Cheers for now. Bye-bye.